Hey folks, thanks for joining us. Another great question that we've had over the last little bit as we're building up with the script top hype is how do we go about reading QR codes inside a TouchDesigner using OpenCV? Because OpenCV has tons of different capabilities built in: camera calibration, QR code reading, feature detection. It's a pretty rich library. So in this example, what I'm going to do is I've pulled up off of the internet, the worldwide magical internet, a guide on how to generate and read QR codes using Python and OpenCV. Literally, I typed in OpenCV Python QR code into Google, and the second hit was this one. So this isn't some obscure piece of knowledge. This is a very common situation here. And we don't need to generate QR codes. We're just going to read them. I already downloaded 2 images of QR codes. We're mainly going to be concerned with reading and tracking these QR codes. So before we dive into that, let's actually just set up our little tracking system here. So what I'm going to do is, as I mentioned, I have downloaded 2 images of QR codes because the reality is in 2020, I do not own a printer to print one out and hold it up in front of my webcam. So I've got 2 images here for different QR codes that are real QR codes I pulled off of the internet. And what I'm going to do is layer these on top of some kind of movie background that'll function as our kind of pseudo, QR code in camera view. And I think what I can use for these will be even something as simple as the stock nature footage that comes with the TouchDesigner installation. So I could say maybe movie 2, and we got some nice blades of, I assume that's some kind of wheat or grass or situation, tall grass. And I'll go ahead and over my QR code right on top of that movie. And the first thing you're going to notice is by default, this is going to be doing some not pleasant things. It's going to have the pre-fit overlay set to fill, which we don't want. So we're going to go ahead and set that to native resolution. And then we can even go ahead and actually set up some of these transforms to be automatic. So I'll go ahead and make an LFO chop. And I'll put a math chop after it. And we know the LFO is going to go from -1 to 1. And in this case, I need my X position to move, probably from 0.3 to -0.3 so that it kind of just slides back and forth from the left and the right side. So I'm going to go to my range on the math chop, set it to be, I know my from range is -1 to 1, and my to range is going to be -0.3 to 0.3. I can put a null chop after that. And then here inside of my over, I can drag and drop the channel onto the translate. And I have my QR code moving around inside the image. On the LFO, I might slow that down a little bit, just so that it's not as crazy. And then like we've been talking about in the last couple videos, I highly recommend always trying to down-res your textures that are going to be going into these script tops and OpenCV workflows because they are very expensive. And as you'll see as we start building this, even when we're finished, it's still pretty expensive and going to make my system run at less than 30 FPS possibly. So I would say whenever you have a chance, it's always good, and not even whenever, you almost always will probably want to put in something like a resolution top or a fit top, and then really drop that resolution down. I think in this case, we could probably even get away with moving down to quarter resolution. We'll see if it ruins any of the actual details of the QR codes coming down this low in resolution. But now we're essentially going to be feeding in this 320 by 180 texture into our OpenCV workflow. So I'll put a null top at the end of that and drop in my script top. Now with my script top, I'm going to open up the callbacks here in my Sublime. And the first thing I'm going to do is, as always, import NumPy as NP, because even though we're not using NumPy heavily in this example, I think it's a good habit to get into. The consensus on all of the internet is that most people are going to be importing NumPy as NP, so any scripts you find, any examples or references are all going to be using this NP dot variation of using NumPy. So when we have that in there, we can go ahead and delete the onSetup parameters elements. We can delete this line 17. That's going to be the math that draws out the random information here, the random noise. And we can start getting into porting over this example code. So we can see the first thing we want is import CV2. So at the top here, I'll also import CV2. And then we dive right into reading our image. Now, just like we've done in the previous examples, I'm going to go ahead and basically take the same variable image, but instead of using cv2.imRead, which is for reading images off the disk, I'm going to access my null2 here and actually pull the NumPy array directly off of it. So I can say equals op null2.numpy array, open a set of parentheses, and I highly recommend usually saying delayed equals true. That'll just give you a much better performing option, because if it's not set to true, it's trying to not only get that data on the same frame, but do your processing on the same frame, and it's more than likely going to slow it down to a crawling halt of an FPS. So now that I have my image data in here, I can even just test this by going to my final line, which is our output script op.copy numpy array, and just feed my image out to it. And when I save it, we should basically see the same top coming out of our script. So great, we can start moving through this tutorial. So it looks like the first thing we're going to do is instantiate a QR code detector object that's built natively into the CV2 library. So I can go ahead and just copy and paste this right into my code here. And then the next thing we're going to see is this line here where it looks like we're using the detector's detect and decode function on the image and then getting a bunch of different variables out of it. So I'm going to copy and paste this in here and talk through it a little bit, because we don't see this style a lot unless either you're more advanced in Python or you've been doing a lot more kind of like data-centric work. But if you've just been doing a lot of scripting and writing these command scripts, you probably haven't seen this format of setting up a bunch of variables all at once. You know, probably you've seen the more common one, a equals 1, or, you know, sum op equals, you know, op null2, and this reference where there's one thing on the left side and one thing on the right side. But actually what you can do is have a bunch of things on the left side separated by commas, and then because this detect and decode has multiple outputs at the same time, it'll automatically assign different pieces of data to each one of these variables. So it's almost like speed running, you know, getting a couple of different variables, their values all at once, instead of having to set one variable for this, then have to then say data equals, you know, that variable and pulling out all the different pieces. We can kind of do it all at once. So you're going to see this probably a lot when you're working with OpenCV, especially a lot of the examples we've been looking at have this kind of notation. So once we get to that part, the next thing we can do is take a look at this code here, which seems to look for the bounding box and then draws a bunch of red lines around it to indicate where that bounding box is. But before we get there, I actually want to look at some of this code, and I'm going to save it, and we're going to see an error come up. And this error is going to be something that you are probably going to encounter quite a bit if you're working with OpenCV and TouchDesigner. And it has a lot of different variations, but it's usually some kind of -215 assertion failed. You'll see something like in arr.depth or image.depth or some kind of variable equals CV_8u. Now, what this CV_8u is a pixel format data type inside of OpenCV. And you can think about this very similarly to how we have different pixel formats inside of TouchDesigner. So if I make a noise top, for example, and I go to the common page, you know, most of the time we never really come down to this pixel format button and change it too much, or if we do, we're just going from 8-bit to 32-bit for noise or more precise data. But there are tons of different pixel formats here. Now, TouchDesigner is pretty nice because it really smoothly handles moving between those conveniently. You don't see a lot of errors when you're going from 8-bit to 32-bit back to 8-bit. Things kind of happen smoothly. OpenCV, on the other hand, freaks out when a function gets a data type that it's not supposed to be getting. You know, it doesn't automatically convert it for you. It just throws up its arms and says, I'm expecting this, you're giving me something else. -215, you know, -215. What are we doing here? So in this case, what we're seeing is that this detect and decode, which we can see is on line 22 here, is expecting something that is in CV8u. And what that means, it's going to be an 8-bit unsigned integer. And if you've ever seen any types of data or examples of OpenCV, you've probably often seen that representation where they show a grid and they show those numbers from 0 to 255, whether there's data in a pixel or not. We kind of have to get to that. And a good way to explore these workflows, if you're completely new to them, is to actually try printing out the different objects and seeing what you get. Now, one thing I'd recommend is when you're printing, because printing, the script top's running every frame, printing stuff out is quickly going to slow down. Oh, we can already see how quickly just the error printing is already slowing down my system. You don't want to have to keep clicking clear. So probably the first thing I'm going to do is actually just comment out this line 22 here. And we can see even just printing out all this data is slowing it down. So I'm going to comment out my print here as well. And you can see once we stop printing, all of a sudden, chaos is held back at the bay. But let's take a look. So right now what I did is I printed this image, which is the NumPy array we get directly off of the texture. And what you'll see is if you're not used to looking at this format of data, it's a lot of lists within lists. So you can always think of the first set of brackets of the list as the whole image container. Then you're going to see another set of brackets, and those are going to be the columns of pixels. And then in this case, inside of each column, we have a list of even more lists, and that final list is going to be each pixel. So in this case, each pixel, which is these little units here, we can see has 4 parts to it. It's got an R, G, B, and A, and all of them are floats. Because a lot of the time when we're working in TouchDesigner, we're working with floats that are between 0 and 1. So, if you've seen constant top or any of these kind of things, we're always setting stuff between 0 and 1 for colors. Now, this is no good for this OpenCV workflow because as we saw, I commented out the error, but it was wanting CV8U, which is 8-bit unsigned integer. Now, those integers, it's expecting are going to be between 0 to 255. Now, right now, we don't really have a lot of built-in ways to deal with those data processing, but there are some easy tricks that we can do. So the first thing we can do is actually, let's deal, because we got 2 battles. One of them is that we have 4 numbers per pixels, it wants 1. And the other is that we have floats and it wants integers. So let's deal with first compressing the 4 numbers down to 1. And we can do that just by grayscaling this image. Now the tough part is we can't grayscale it or monochrome it inside of TouchDesigner because we would still have, different values that are all going to be floats. So we can use something that we used in our previous videos, which was the convert color function inside of OpenCV, which is going to be a lot more resilient and a lot stronger. So for example, what I could do is start a new variable called gray, which is going to be my grayscale version of the image. It's going to be cv2.convertColor, and we have to give this function 2 different things. One of them is the texture we want to manipulate. So in this case, it's going to be image. And the other is a flag that's going to tell the function what we want it to do. And these are going to be all kind of predefined. If you go look at the documentation for OpenCV, you're going to see it there. In our case, we're going to use one that is called color RGB to gray. And that's going to tell this function, we're giving you RGB, give us grayscale back. And what we'll see is if we clear out the text port and print out gray, and remember, I'm ready here to comment this out because I don't want my text port flooded. We can see the data structure is immediately a lot simpler. We still have our first set of brackets that are the image, and then you can see we have our next set of brackets, which are the columns. But in this case, each one of our pixels is now just one value, one monochrome grayscale value, not RGBA anymore. And that's why we're one list depth less in this version of our data than we were before. So that's great. So, we've already solved one of those battles. We went from this 4-part piece of data down to this 1-part piece of data. Now what we got to do is get to integers, because now we're still at the 0 to 1 floats. Luckily, this is just a really simple case of math. So for example, what we really need to do, which you can think about it even in terms of operators in TouchDesigner, is like a math chop. If we take a constant chop here, plug it into a math chop, and we know this slider goes from 0 to 1, those are the pixel values. when we want to change this to go to 0 to 255, we just take our to range and go 0 to 255. And now as we move this 0 to 1 slider, we have this range of 0 to 255. And that's really simple math that we can do very quickly, especially because we know that we are always in 0 to 1. It's a normalized pixel value. We're not going to get -3 all of a sudden. That's not going to happen. So to do that, we can almost say something as simple as, let's overwrite our gray data here with gray multiplied by 255. So essentially we take that 0 to 1 range, multiply it by 255, and we're going to get 0 to 255. Now the trick is that we're still dealing with floats here. So we're still going to have numbers that are 0 to 255, but floats. Now the nice thing is that NumPy has a lot of built-in functionality for getting us between these different types of complex like pixel formats and data structures. And one of the ones we're going to use is called as type. And this basically takes this data, gives it back to us as the type that we define inside of the parentheses. And in this case, what we want is an NP, which is NumPy, uint8. And the uint8 format in NumPy is going to be the same as the CV_8u. That's the same format. So we can go ahead and save this, and let's print out a few frames of this new value. And we can already see now this is looking much more like something you might see in like an introductory OpenCV tutorial, or when they try and do those visual representations of the data, because now we basically have columns for each. We have a list for each column. Each pixel is just a single integer from 0 to 255 based on the amount of data inside of it. So that is really important because you are probably going to see that a lot of the time as you start getting into more complex examples with OpenCV. And hopefully as this script top kind of evolves and rolls out, we'll see more and more features added to the NumPy array so that hopefully one day we can just put a flag in here that says, uint8, and we don't even have to worry about doing these extra kind of conversions and little bits of math on top of our data. But now so that we're ready, what we can do is go ahead and uncomment this detector line. And it's given us an error because I'm still feeding an image, so I'll go ahead and feed in gray now instead. And you can already see immediately, I'm now at 20 FPS. And this is why these workflows really, really, really benefit from lower resolutions. And we'll come back and play around with those resolutions, but the lower the res you can send in, the faster it's going to perform. So now that we've got our detector set up and it's working and there's no errors, the final thing we want to do is set up this little bit of drawing and just see if it's actually tracking. So I can go ahead and copy this whole block here, and I'll go ahead and paste it right into my code. And this is something that you're probably going to encounter if you're not used to kind of bringing in Python examples from the web into TouchDesigner. But Python really freaks out when there is a mix of spaces and tab indentation, and it'll give you some kind of error that says, unexpected indentation and spaces. So an easy way to detect this is either if you get the error, you'll see it. The other one is if you just highlight your code really quickly after pasting it. Tabs are represented by these long lines, and you can actually even see inside of the TouchDesigner text dat. I guess I got to save this first for it to show up here. Tabs are represented as dash, 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 and then a forward arrow. And then in most cases, you'll see spaces are represented by single dots. And in most cases, 4 spaces equals a tab. So we got to do a little bit of negotiation here. I personally prefer tab indentation versus space. I know lots of people who do spaces instead. However you want to do it, you can even just go in, delete the spaces manually if you don't want to worry too much about it. You could use some of the functionality, like for example, Sublime can do multiple lines at once, and it's going to change the indentation level and overwrite it with tabs because that's my default. However you want to do that, you got to get that out of the way. Otherwise, you're going to have these weird errors that for no reason you're like, why am I having this error? Once we have that set up, I'm going to indent all of it just to make sure that it is the correct indentation level in my project here. And I already, before I've saved it, I see a print statement here, and I'm just going to comment it out because I know that's going to slow down, the project. I don't want extra print statements slowing down the project. I mean, we haven't even talked about this function yet, but already we can see that it's working. It's drawing these red bounding box lines around the QR code. And we'll come back and talk about the QR code in a second. But let's talk through this code really quick. What we're seeing is that it's pulling off of this B box, which is the bounding box variable. It's doing an if statement to check to make sure there is a bounding box. There's no data because it's not finding anything, you're going to get a none. So as long as it's not none, then we go into this area where it counts how many lines are inside the bounding box, and then just does a for loop through them and does a simple cv.line drawing on top of our image to put, red lines all around that. Now, if you watched our last video where we're talking about pulling data out of, these kind of workflows and doing that drawing natively in Touch, we highly recommend going down that road, because if you start to draw a lot of things inside this Python context, project is really quickly going to slow down, and you probably won't be getting the kind of drawings that you want anyways. You're better off exposing this data, which, for example, if we go ahead and just print bbox a few times, we can see it's a list of lists, and each of those lists has a list in it. But if you ignore how many lists there are, because I think one of them is pretty unnecessary, we can see they're pairs, and these are actually pixel coordinates of each corner of that bounding box. So you could easily take these, write these to a chop, write these to a table, put those in Python storage, do a couple more calculations if you want to calculate the centroid, like the middle of the object. If you want to draw your own lines, you could do that with SOPs. But anything that you could do with this inside of TouchDesigner is going to be much faster than if you did this inside of the OpenCV context. But for this example, that's fine. We'll live with the OpenCV context. So essentially with that, we've really already got this setup complete, right? Like after this, the tutorial goes into displaying that image, but we already have that set up in our situation. They've got capturing devices natively, but we don't need those because we could just easily swap in a video device out or video device into this area. So this is the bare bones setup of getting QR codes scanned inside of TouchDesigner, getting that data if you need it, getting some kind of drawing and visualization. And a good example of, let me put this in the background here so we can see it doing this thing. So, if we swap this QR code with another one, it gets tracked. Let's see here, let's try and scale it down a little bit. Now, one thing you'll have to be careful of is, because we are crunching down the resolution, is at a certain point of crunchiness, especially with QR codes, which are very detail oriented, you're going to lose so much detail that it won't be able to scan those QR codes. So that's something to be careful of as you're working with scaling and sizes. But you can see, I can fully rotate this and do all kinds of crazy stuff, and it has a pretty good lock on that QR code. Hey folks, thanks for watching. If you're serious about learning TouchDesigner and getting into our interactive and immersive industry, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner interactive professionals. You can click the link in the description to learn more about that. And if you liked this video, hit that like button. And if you're new here, don't forget to hit subscribe and click on the little bell icon for more awesome free content.